back to Professor Femmy discusses more math, or actually discusses the underlying math to our curriculum. So, one of the most important subjects, one of the most important um, math topics in real life, including our courses in LOSC, is calculus. Not only calculus, but linear algebra as well. Now, the calculus is basically just the math of change, how things change. So, d over dt, d over dx, stuff like that. Integrals dx or integrals dt, something like that. Or even maybe systems x. But unarguably, the most important topic in real life actually that stems from calculus is differential equations. Now, you guys probably know this because I discussed it so many times. I discussed differential equations in Calculus, and describing behavior using them, because really they're a good way of modeling things that change. So, like a moving car, a rocket shooting into space, or the behavioral patterns of a femboy, those can be described through differential equations. Now, what are differential equations, for those who don't know yet? Well, the course Calculus, actually, I require you guys to actually already have an understanding of what differential equations are, how to solve them, how to figure out if they don't know, if they can't be solved, and just have knowledge about calculus. So it's actually a bit overwhelming if I don't explain it first. So I'm gonna explain or clarify what a differential equation is. So a differential equation is like a normal equation. So you guys know equations like a squared plus b squared equals c squared. Or a squared plus b squared equals 1. Or the absolute value of a plus the absolute value of b equals 1. Or something like ax squared plus bx plus c equals 0. Or y equals mx plus b. This over here is the Pythagorean theorem. This one over here is the equation, the basic equation for a circle centered at the origin. This here is the equation of a square centered at the origin. And this over here is a quadratic function. And this over here is the equation of a line. Now, you guys know these things. They compose of various variables that represent or are stand-ins for numbers. So A, B, and C, as they say, A, B, C are elements of the integers or the real numbers, R, Z or R, but mostly R. So A squared plus B squared plus C squared is part of the real numbers. And so this over here, A and B, are basically coordinates that stand on the circle. So any coordinate that satisfies this condition, such that the square of the first coordinate plus the square of the second coordinate equals 1. So actually, this is mostly written not as a squared plus b squared, but rather x squared plus y squared. Because the y coordinate, or the square of the x coordinate plus the square of the y coordinate, will always equal 1, as long as that point is on the circle. Now this is actually x also, the absolute value of x and the absolute value of y. And I'll explain the absolute value symbol in a different video, or maybe a separate channel, because it's not really the place for it. So these are regular equations. These are equations wherein you want to find, or given two known variables, you want to find a missing variable, or a variable. So we know we're given the values of A, B, or C, and then we are told or asked to find values. So an equation like 2x equals 4. It's called an equation because we are equating two things. We are stating that two things are equivalent, are equal. And so, in an equation with an unknown variable, or a variable which does not have a value, or a value that we do not know, we want to find that value so that the equation is true. So if we were to follow through with the regular rules of algebra, we just need to divide both sides by 2, and you get x equals 2. And so this answer, x equals 2, satisfies this equation if we put it inside. 2 times 2 is 4, and you guys already know this. 4 is equal to 4, and that checks out. No need for a proof for this unless you want advanced mathematics to prove that. So let's jump into calculus territory and discuss the derivative. So what is a derivative? It requires some, the concept of derivative requires what is known as a limit, or a limiting process. And a limiting process is basically us finding out what a function approaches as its x values, or its domain closes in on a value. I already explained limits in my origin channel. I think I'm gonna link the video in the description below so you guys can check it out. So a derivative of a function, so we know functions, right? They're graphs. They're things that take an input x and spit an output y. They're machines that tells us coordinates, or corresponding coordinates given an initial coordinate. So given an x, they give us a y. That's what functions do. And the most intuitive way to describe the derivative is rate of change. So if this pencil is traveling along the paper, so it's moving along the paper, it's the derivative of the function that describes its position on the paper, basically tells us its velocity, or its speed, how fast it's going. So the derivative of x, which we normally call the position, with respect to time, is the velocity. This is what velocity, v, is formally defined as. And so from there, acceleration is simply just the derivative of velocity with respect to time. Or the second derivative of position with respect to time. And we denote second derivatives or higher order derivatives via exponentiation. So we just use 2 up here, and then we use 2 up here or down here to denote that we are taking the derivative twice of the function x of t. And there are these things called partial derivatives, wherein if we have a multivariable function f of x, y, the partial derivative is what its name states, half of the story. So partial of f with respect to x. So this tells us to take the derivative of f with respect to x, ignoring y, treating y as a constant. And likewise, derivative of f with respect to y. Derivative of f with respect to y. Now that you guys know what the derivative is, I think I'm gonna make an in-depth topic some other time. So I will write down the formal definition of what derivative is and explain it to you guys here. So the derivative is characterized by this equation. So f prime of x equals the limit as x goes to 0, f of x plus h minus f of x over h. So we can think of this, or I'm gonna draw a graph. Let's say this graph is the graph of f of x, and we wish to know how much the function changes. Alright, we want to know how much the function changes. And to know how the function changes at a point, let's say this point over here, we need to find its derivative. So we can say that the derivative is on a function on a function that gives us sort of the inclination of a line that goes through it. So tangent line. This describes its slope. So how steep this tangent line is described by the derivative at this point. So with that, we can tell whether the function is going up or going down, or is it flat or what at that point. But I must state that the derivative does not immediately tell us what the next point is or what the behavior is gonna go, how it's gonna flow, because it can just stay like that and we think it's just gonna stay like that for the entire graph. No, that's not how the derivative works. It's a sort of successive machine that we use successively to find the slopes of the line, but it doesn't tell us intrinsically what the behavior of the function is all throughout, because it's taken at all points of the graph. By nudging it just a small bit, just a small amount, delta x, and taking the rise over run, which we know to be the m of the equation of a line, which is slope. Okay, now that you guys know what a derivative is, what is a differential equation? I've been beating around the bush this entire video. It's time to get to it. So, a differential equation is an equation involving derivatives. So, dy over dx plus d squared y over dx squared equals 0 is a differential equation. And so is the differential equation dy over dx equals sine of x. This is a differential equation. And we can sort of apply that. Let's use partial derivatives. X squared f dx squared plus squared f over dy squared plus d squared f with the z squared, all multiplied by h, or minus alpha. I'm gonna put the minus alpha on the front, so it's a multiplication. Is equal to df over dt. So minus. This is the heat equation, and it is also a differential equation. So to go with differential equations, like how we wish to find unknown variables, is that we find the function. So we're trying to find a y that satisfies this equation. And there are many tools to find differential equations, but the most common thing to do first is to check whether we can solve the differential equation with simple methods, or we would need to break out the big guns, such as numerical approximation and stuff like that. So in this differential equation over here, dy over dx equals sine x, we just need to take the integral of both sides. And we can think of the integral as an area under the graph. But let's just think that it's something that we do to cancel out that derivative. So dy over dx equals sine x, and then we just take the integral of both sides. As you know, that dy dx cancels out, and then we just take the integral of sine to find that y. And so that's actually cosine of x. So we found the function. That's the goal when we have a differential equation. The most important thing you guys need to know when we are trying to solve a differential equation is what we're trying to find. And that thing we're trying to find is the function. Now, Calculus deals with more advanced topics in the field of differential equations. This is just an introductory video I'm giving you guys so you guys can understand what a differential equation is.